Okay, so here we've got the production of polylactic acid. So we start out with plant material, such as corn and potatoes, which we can easily extract the starch from, right? So we get starch, and then by adding water to that, or hydrolyzing it, we can end up with just individual glucose molecules, which is then fermented using one of two enzymes, or one of two organisms, so the rhizopus fungi, or the lactobacillus bacteria. And so that just ferments the glucose and turns it into lactic acid, which is our basis for this polymerization. So here's our lactic acid. I'll only go through one method due to time constraints. This is the most common method. So method one, we condense the lactic acid, so remove water from it, and we end up with this cyclic dimer known as lactide. So it's called a cyclic dimer because there's two molecules and it forms a ring. And so then we use a ring opening polymerization, which is exactly what it sounds like: open up the ring and polymerize with other lactide molecules. And this forms polylactide, which is also known as polylactic acid. And N is just the number of monomers in the polymer. So there's two main properties of polylactic acid. The first is that it has a low melting point and a low glass transition temperature. And the glass transition temperature is basically just the temperature at which plastic goes from a hard glassy material into a soft rubbery one. This means that PLA can be used for thermoforming packaging and heat sealing. The second property is that it has a high level of vapor permeability, which basically means the plastic is very breathable. So you can easily put ready-to-eat vegetables in it, such as these salads that are here, and that's obviously useful in society. So in this video we learned the production of polylactic acid through the fermentation of glucose and the polymerization of lactic acid. We talked about the properties of PLA, that it has a low melting point, low glass transition temperature, and vapor permeability. And we discussed its uses in society, in that of thermoforming packaging and in ready-to-eat vegetables packaging. Thanks for watching.